Okay, this is Mr. Peterson returning to the notes 1.5C for Algebra 2, and we're on the third and final page of this note set. So what I have in this first example number 8 here, is, excuse me, let me go back. What I have is three inequalities, the first one being x has to be less than 6, and then y has to be greater than or equal to negative 3. Those would be a vertical followed by a horizontal line. And then we have one that we haven't seen before in this course here, but you should have learned in Algebra 1. I will be trying to remind you. When it's got a squared to it, you're going to get a shape that's called a parabola. It might look like that, right side up parabola, or in this case, we're going to get an upside down parabola. And I'll try to remind you of how to graph that if you haven't had that for probably over a year. Okay, when it just has x in it, it's a vertical line. So I'm going to find x equals 6. 6 to the right. There's a bunch of millions of other points that are 6 to the right. I'm highlighting all of these that are 6 to the right. And since it doesn't say anything at all about the y, you can go any height you want, which is why I made some of them up, some of them down. Now it has it has less than, but not the or equal to. So this border that we're going to draw here has to be a dash border. So let me get it drawn here. And that simply means that the border is not part of the solution set. Okay, we discussed this earlier. When it's x is less than, you're going to shade to the left of that. So I'm just going to make a little mark here. We want to be on the left side of that line. And that means all this area here we will never write anything on, okay? So you're going to be shading on the left of that dashed line. Okay, the next one, it just has a y in it, and I trained you briefly that these are these are solid. I don't know what I'm talking about. These are horizontal lines is what I meant to say. So horizontal line, and all of them are y values that are negative 3. So the most obvious place that y is equal to negative 3 is on the y-axis, but it doesn't tell us we have to do that. We just have to stay down 3, and you can do any of these points that are down 3. So we get this horizontal line, and with the or equal to, let me show that to you. It's got the or equal to there. We want to make sure that we use that solid border. Okay. So it says, if you look up there, it says y is greater than this. So we want to be above that line. So we've narrowed the area to, at this point, if we just stopped here, it'd be this area right here. But we have this third constraint, or this third equation to deal with, inequality. And I'm going to do this in blue here. Now, this is new information for you as far as this course, but I'm hoping you've seen it before. What you're going to do with these x squared ones is you're going to take the part that's being squared, and you're going to come over here and set that equal to 0. And what we're going to do is find the x value at the vertex. It's going to be where this thing turns around. We're going to find that x value. If it's upside down or right side up, you find them the same way. Okay? And the reason for this is, well, the number that you square that would give the lowest answer or the highest answer would be 0. 0 times 0 is 0, and you can't get any smaller than that. So if you set this equal to 0, the upshot is you'll be able to find the x value you should put in the middle of your graph. And so you're going to put that in the middle of your t-chart. So whatever you're squaring, set that equal to 0, solve for x, and put that in the middle. Now some teachers only require you to do 2 points on each side of that middle one. I require 3. So we're going to go 5 and 6 and 7. That'll be on the right, and then 3, 2, and 1 when you go the other direction. Okay, so let's find the middle number first. Let's find this value. And you're going to get that by putting a 4 right there. So 4 minus 4, you do that much first, would be 0. 0 squared is still 0. The opposite of 0 is still 0. And 0 plus 8 gives 8. So we end up with 8. So let me find 4, 8. It's going to be right there. And we got one of our points. Okay, now I'm going to put 3 in, and let's see what happens when we put x of 3 here. 3 minus 4 is negative 1. Negative 1 squared is negative 1 times negative 1 is 1. And you change the sign, so now we have negative 1. Add 8 to it, and you get 7. So that would be that point right there, 3, 7. On the other side, you're going to find out that we're probably going to get the same answer. You should, if you've done everything as I've indicated so far. So we're going to put 5 in. 5 minus 4, you do the inside parentheses first, is 1. When you square 1, you get 1 times 1 is 1. Change the sign, we now have negative 1. Add 8, and you get 7. And that is good news because we should get matching values on either side of the center point. So you get 7 on both sides. Now, once you have that, you can take advantage of that feature. You can copy these. I'll show you what I mean here. 2 minus 4 is negative 2. We're putting 2 in. Negative 2 squared is 4. 4, when you change the sign, is negative 4. Negative 4 plus 8 is positive 4. And you just put a positive 4 in the other one. So that would be this point and this point. One more. Let's put in either 7 or 1. They give identical answers. So let's do the easier one. Let's put in 7. 7 minus 4 is 3. When you square that, you get 9. The opposite of 9 is negative 9. Plus 8 gives negative 1. Now, if you went to the trouble to find the other one, you'd get negative 1 also. So now you can kind of see the pattern of where these are going. And we want to shade below that parabola with a dashed border. So let me make a dashed border here. And once I've got this drawn here, I'm going to indicate, and this would be based on the fact that y is less than, that we have to be below that parabola. Okay, so if you're above the green line to the left of the red one and below the parabola, then you're in this little area here that I'll indicate. And you just kind of outline it like this. Stay on the left of that red line there, don't go past it. And come across like this, and then shade the rest in. These are the millions of points that would work. Anything outside of that region would not work. And if you're shading this with a pencil, you just take diagonal lines parallel to each other, and don't scribble, do a neat job, and try to stay in the lines, don't go out. Okay, so that's the other way of shading it, either with a light highlighter or just a pencil. Okay, now there's a similar shape that we're going to get on the next problem. And I'll point out that this part here is called an absolute value. And what you do is you calculate the inside part of that and then change the sign to positive. Absolute value forces things to be positive. Eventually it goes back to negative when you tack that on it. But anyway, we'll cross that bridge when we get there. Okay, the first thing I'm going to do is the top line right here, the one in red. And it says x is greater than or equal to negative 4. So there's a point that's 4 to the left. Here's another one. Here's another one. You can see pretty quick that we're going to be staying, we're on that vertical line. So let me draw a solid border there. And the reason I know it's solid is got the or equal to. You want to be on the right side of that. The greater than in this case means you got to be to the right side of that. And just leave it at that for now. Okay, now we have a horizontal line. I'll do the one that's color-coded in green here. The y value is all there is. This will be a horizontal line up at 6. So here's a point where the y is 6, but there's millions of other ones. They're all along here. So you just color them there. And this time it doesn't have the or equal to, so I picked the dashed version of the line. And I draw that horizontal line. Let me get it lined up good. And with with less than, we want to be below. So we want to be below that line. Now, if we stopped right here, the region that we would be shading is below the green one and to the right of the other one. We'd be shading that area, but no go. We got one more thing to do here. Okay, just like the parabolas, the ones with the squared in it, these ones with absolute value, you take the stuff inside the absolute value and set it equal to 0 and solve for x. And that'll tell you what to put in the middle of your x's on the other side. So that is the x value where it's going to be a V shape, either like this or like that. And in this case, it's going to be an upside down V. Okay, the bigger numbers starting at -2 would give -1, 0, and 1. And if you go the other direction, -3, -4, and -5. My standard is 7 points here. So we're going to start with the middle one, this one right here. -2 plus 2 is 0. The absolute value of 0 is still 0. Change the sign. -0 is still 0. -3, and 0 minus 3 is -3. So that would be this point right there. That's going to be the point of the V when we're done. It's called the vertex. Now, the next pair, we should get similar amounts if we've done everything right. Well, the same amount right in those two slots. So we're going to calculate the -1 to start with. We're going to find this one. -1 plus 2 is 1. The positive version of it's still 1. Change the sign. Now you got -1. -1 minus 3 is -4. Now, if all's well, you should get that value here too. So it kind of serves as a check. We're using -3 here. -3 plus 2 is -1. The absolute value of that -1 is +1, but then you change it back to -1 and take away 3. Okay, we've got enough confirmation. These are going to match, and these are going to match. Both parabolas and these V-shaped ones with absolute values work this way. Okay, so let's try -4 in there. -4 plus 2 is -2. The absolute value of that is +2. Change the sign to -2 again, -3, and you get -5. So let me catch up by plotting these. We had this one was -2, -3, but then it went down to a height of -4 on both sides of that, and -5 were the last two that I just did. Okay, we're going to do 2 more here. -5 plus 2 is -3. Absolute value is +3. Change the sign, you're back to -3. -3, you'll get -6. And this one will be -6 too. And you can plot those and you can see where this is going here. It's a V. Now with the or equal to there, it'll be a solid border. I'm going to choose that option on my program here. And, wrong color. Okay, so this absolute value function goes down like this in both directions. V-shaped graph. That's what you get with these absolute value ones. And it says greater than there, so we have to be above that border. Okay. So the region that we want to shade has to be below the green one and to the right of the red one, but also above the V. So let me outline it. It's kind of a weird shape here. We got to be below that border, to the right of that one, and above the blue one. Okay, so this is the area. It's going to take some work to get it shaded in here. That meets all those descriptions, okay? And once it's all shaded, I'll remind you how to do this with a pencil instead of a highlighter. Okay, you just simply take your pencil, and you never want to go in the direction the horizontals and verticals because you want to cross the grid marks like so. Go diagonally and make sure you cover the whole area like so with these parallel lines, and that's an acceptable way to finish this problem. Okay, so I hope this does it for you. And if not, you guys know you have time to come back and see me and get some more pointers. But that does it for the notes for section 1.5C. And you guys have a sweet day.